So we just have a couple of more topics to talk about. I wanted to talk about those topics. One topic I wanted to discuss is a culvert design using HY8. HY8 is a culvert analysis software, so you can use it for designing culverts, which are, you know what culverts are? Okay, so you know about culverts. And this is a culvert. It's a pipe under the road, usually, or an embankment. These are the different culvert types. So you can have circular, box, elliptical, pipe arch, metal box, and arch culverts. And culvert analysis is a little bit different than regular hydraulic analysis, regular open channel, because you have different situations. One part of culvert analysis is there are two situations you can end up with. One situation is you can have inlet control, and that means the water above the culvert, the water in front of the culvert is controlled by the inlet. And the other kind of condition you can have is called outlet control. That means the water is controlled by the outlet depth, or the depth of the outlet. And there are different orientations of culverts you can have, and different things to consider. So these are some examples of culverts. This is a culvert system. It's 4-barrel culvert. Here's another culvert. With this culvert, actually this guy right here, so this is the guy at the bottom of the culvert. These are some people at the top, and it eroded away down here, so it's kind of created a problem for that culvert. Here's some other culverts. You got to be careful about erosion. Here's some culverts. Have you ever seen this? You have snakes in the culverts. Here's another culvert. This is in Florida. These guys, this alligator, they're installing some pipes, culverts. So HY8 was originally written in DOS, so it was a DOS program, had a DOS interface. And Aquaveo upgraded HY8 to have a Windows interface. And it's based on the U.S. Federal Highway Administration manual. There's a manual called HDS 5. HDS is Hydraulic Design Series Manual 5. It's based on that manual, and also it's based on HEC 14, which talks about energy dissipation. Usually when you do a culvert, if you have fast flow coming out of the culvert, you'll want some way to dissipate the energy out of the culvert, and so both those methods are used in HY8, in the HY8 program, the HY8 model. It's also we get information from pipe manufacturers and use that information. So HY8 does culvert analysis and design and energy dissipation. There are some other functions that I'll show you here in a second how to do those. So in HY8 there are 3 different terms you need to know if you're going to design culverts using HY8. A culvert is just a single culvert that has one or more barrels. So this right here you could model as a single culvert with 4 barrels. So that could be considered a culvert. A crossing is one or more culverts at a given site. So you could have different culvert types at a single location, and that's called a crossing. So if you can have more than one culvert at a single location, is called a crossing. A project, an HY8 project, could have one or more crossings, so you could have several different sets of culverts at different locations, and those could be stored in the same HY8 project. HY8 is, in HY8 you can have up to 6 culverts at a single crossing. You can have any number of crossings in the HY8 project, and HY8 computes inlet control and outlet control headwater elevations for any given flow. So the way it does inlet and outlet control is HY8 calculates the inlet and outlet control headwater elevations for several discharges. You define the discharges. The larger of the inlet and outlet control is the answer for your headwater above your culvert. And you can do overtopping and multiple culvert analysis. That's done if necessary. So this is the inlet control equation that's used in HY8. HY8 just uses, this is called a fifth order polynomial, and it's fit to a curve that we use. And so we define these coefficients. You define these coefficients, or these are defined in HY8, and HY8 computes the headwater for the flow rate, the different flow rates, depending on the slope, and it depends on the slope and the culvert rise. This D is the culvert rise. This is how HY8 computes outlet control. So the headwater at the outlet is equal to the headwater, the tailwater depth, plus the friction loss, plus the entrance loss, plus the exit loss. And to do culvert analysis in HY8, you have to define all this information. This is a picture of HY8. This is a side view of a culvert. So this is a top of the roadway here. This is your pipe under the roadway. This is the embankment. Usually you're going to have an embankment on a road, and then the culvert will be at the bottom of that embankment. And this blue surface is the water surface profile under the culvert. The other thing I should mention is that if you run HEC-RAS also does culverts, so you can add culverts to a HEC-RAS model, and it uses a similar process to HY8. HY8 is just an easy way. If you need to set up a culvert, you can do that in HY8. You can view a map. You can bring in a map of your area and add culverts at different locations on your map. You can also do show a front view of your culverts. This is the headwater elevation, and these are your culvert barrels, and then this is the roadway top. This is a side view, like I explained. So headwater elevation here, the tailwater elevation, and then this is the culvert profile. This red line is the critical depth. And then your culvert barrel is here, and then this is the top of the roadway, and these are your embankments. So to do an HY8 analysis, you just define your culvert data. You figure out where your culvert is. You define your culvert data, your crossing data, your culvert data. You run your analysis. You can modify your culvert design if you need to, and then you can create a report in HY8. So more information about HY8 is available on these websites. There's a help page on the XMS wiki that talks about HY8, and there's also the Federal Highway Administration distributes, the U.S. Federal Highway Administration distributes HY8, so you can go to this website and download the HY8 program, the latest version. Okay, so let's set up a culvert in HY8. I'll just show you how this works. So this is HY8. When it starts up, it asks me if I want to create a new project or open an existing file. And I'll go ahead and create a new project. And then I enter some HY8 data. So let's say I will have a design flow, and you can use either US customary or metric units. Let's use metric units since we're in Egypt. And we'll do a design flow of maybe 3 cubic meters per second, and our maximum flow maybe 10 cubic meters per second. And you would get this from running your hydrologic model in WMS. And we'll do a bottom width of, this is for the tailwater, so we need to find our tailwater information. And the bottom width, we'll just say use a rectangular channel with a bottom width of 2 meters, a channel slope of 0.01, and a Manning's roughness of 0.045. Then we'll do enter our roadway information. So let's say we have a paved roadway with at an elevation of 10 meters. The top width is, let's say, 10 meters. And the crest length, that's just the length that HY8 uses if you have overtopping over your roadway. Just enter 100 meters. Then we enter our culvert diameter. So let's say we have a culvert with a, and this is in millimeters. So that's, I'm going to enter 1,000 millimeters. So that's 1 meter culvert. And we'll just use these default options. And then I'll define an inlet station at 0, inlet elevation, we'll do 0.2 meters, outlet station, we'll do 40 meters, and then outlet elevation, we'll just use 0. Then I can run this. So when I run this, this is what HY8 gives me. This is the top of the roadway. These are the embankments. This is my headwater. This is my tailwater. And I can show the legend here, and it'll show me what all of these things are. And so that's my culvert design. And if that works, then I can just stick with it. If it does not work, I can change the diameter and try something else. So let's change the diameter to maybe 2,000. And that's what would happen in that case. In this case, I actually have a hydraulic jump, so you can see this hydraulic jump in the culvert. So that's how HY8 works. That's pretty much all I wanted to say about HY8. Are there any questions about this program? It's pretty easy to use. The other program I wanted to mention is it's called the Hydraulic Toolbox. The Hydraulic Toolbox is included with WMS also. You can download it from the FHWA. This is the Hydraulic Toolbox, and it has several calculators. So the Hydraulic Toolbox has several calculators in it, and this is the toolbar that has a list of all the different calculators. And I can do metric units in the Hydraulic Toolbox also. You can do channel design, channel lining design, so like riprap. You know about riprap? Okay. And weir design, curb and gutter design, rational method. You can do the rational method in the Hydraulic Toolbox. You can also do detention basin design. There's a separate module for riprap analysis, rock sediment gradation analysis, median ditch drop inlet analysis, culvert assessment, and this just is used to manage your manage culverts, bridge scour analysis, horizontal grade inlet analysis. So these are all the tools that are in the Hydraulic Toolbox. And like I say, so the U.S. Federal Highway Administration uses this to do their highway design. model their highways. The other thing in both of these tools is they have a good reporting tool. So if I select this option to create a report, I can generate a report that has a picture of this culvert and all of the computations that are involved in this culvert. So WMS, so the HY8 will save out a report file to Word. And so here's the report file, and it has all the culvert input data as well as the output data, and it has some plots and just kind of a culvert summary. And the same tool exists for the hydraulic toolbox. I can select one of these analysis. So let's design a little channel here, and I can enter a flow rate, let's say 3. And then, so this channel calculator calculates just uses Manning's equation to calculate my depth in the channel. Then I can do a report for that analysis. We'll just save that here to the documents. And that report, and Hydraulic Toolbox will create this report file. It has the information about that channel analysis.
He's going to change all the certificates. So if you want to do documentation,
So any change you want?
It's up to you guys. It's okay. This is okay for me. But it says hydrologic and hydraulic modeling. Did you want with WMS or not? It doesn't matter to me. I mean, this is for you. If you want to put it up on your wall or something, you can.
review it. So if you want to modify any modification, because it's going to reprint it. If it's okay, so we can keep the old one.
This is okay. I'm okay with it.
تريننج على الهيدرولوجي والهيدروليك.
طب الرقم اللي اتغير هو عارف عشان الرقم اللي اتغير.
لا انا قصدي كده، يعني لو حد هيعمل حاجه، حد مثلا بيفكر شويه يشتغل في مكان، المفروض يديك دليل ان هو اشتغل ده من الناس. تمام؟ دي كده ما فيهاش استثناء ده من الناس. ليه؟ يبقى بيسال سؤال محدد.
يعني انت شايف ان احسن نحط فيها دليل؟ I think they better to add
احسن تعيد ولا لا؟
The WMS. Okay.
الهيدروليك دي في مليون
حاجه صح؟ لازم
حتى لو
حد
خدت كورس في الجامعه
بالظبط.
كلهم مفتوح كده يا جدعان.
لا يحدد.
It's right here. So hydrologic.
انا طبعت مره مش عايز اطبع تاني.
بص يا باشمهندس.
Hydrologic and hydraulic modeling with WMS.
بص يا باشمهندس، اسم الكورس ده
Hydrologic and hydraulic modeling with
with water
the watershed model.
دي افضل.
Okay.
Or it could be just WMS. It doesn't have to be
With
watershed
WMS.
modeling.
انت ممكن تعملها ايه؟ يعني ممكن نرفع دي فوق شويه. احسن نرفعها شويه ونضيفها كلها.
ايوه ووتر شيد موديلنج سيستم تحته ممكن.
Do you want to change anything else?
I don't.
You
I think those are
you will
fine.
sign it.
Just use that. Just use that. It's okay.
You can post it.
Unless you want the
can sign both.
3.2.
If you
You want 3.2 or you want 2.8?
doesn't matter. Think it, anyone can understand what it is.
No, if we reprint
I don't know.
I don't. Nobody knows. I'm the only one who knows what that means.
It's not about 2.8 or 3.4. If we reprint to add WMS. If we will
If
not
you
add
read-
it, then this is fine. I think
maybe we give the vote.
root.
Yeah.
اللي
مين اللي عايز يعيد تاني مع الدم مقاس ومين اللي مش فارقه معاه؟ ده ايه؟
محمود فيها هيوافق على ال
9 out of 15. ادي
ايوه
بس الان جنب احمد صلحها دايما صلحها دايما عشان ما يطلعش فيها حب غلط لو حد يبص معايا يا جماعه يراجع برضه الاساسي عشان ما يبقاش فيه خطا تاني.
Doesn't he have to change everybody's, so he has to change each person's file? Is there a separate file for each person?
No.
I think you just copy this.
He just puts the names in? Seems like a lot of work. Okay, that's all.
That should mean we reprint for the only person who wants to change? Or
You could, whatever you want. It's up to you guys.
اللي مش عايزها تتضاف ياخدها زي ما هي. ماشي؟ خلاص دي الدكتوره زي ما هي.
بس ما ينفعش الناس هي شهاده ثابته كل
لا عادي مش هنقدر نقدم مع بعض.
He said I'm not going to use the certificate at the same time because I said we have to unify all.
بس عبد اللطيف اعمل نسخه كمان كل واحد ياخد
لا مش هيقدر يدي لك اتنين. لا هو كده توفير للطباعه ومجهود اللي عايزها زي ما هي. ولا كده ليه معاك؟ الدول العربية يفهم حاجة واحدة بس يسألك سؤال صريح والله العظيم كده تعرف اديله بقى دي واحلف له ان اقوى بيه هو اللي عملها.
لو الدكتور ما يقولش ده مش هنستفهم
All right. Are we okay? Figured that out. So, the other thing I wanted to show you is you can WMS kind of has WMS has something called the HY8 modeling wizard. And if you want to set up an HY8 model in WMS, you can step through this wizard and set up an HY8 model. You can also bring up HY8. So if I want to bring up HY8 from WMS, I click on this button. WMS brings up HY8, and you can also bring up the hydraulic toolbox from WMS. And there are different tools that allow you to do things with HY8 and with the hydraulic toolbox in WMS. And if you want an overview of those tools, there is a PDF file that you have. So this 1B optional 1B workshop. This talks about how to use HY8, the HY8 modeling wizard in WMS. So use WMS to get your flow rates and stuff for HY8, and then you can run those flow rates through HY8, and you can do several things that with the help of WMS. There's also a basic HY8 workshop that I included, and this just shows you how to set up an HY8 model and kind of explains things, how to set up an HY8 model. So the other thing I wanted to talk about was reservoir modeling in HMS. So let's I'm going to open some files here. This is Sinai. So I'm going to open my Sinai files. And we'll read in our images, our DEM data. So here's my DEM. I'm going to convert that to my TIFF DEM. I'm going to convert that to a DEM. So I have a DEM now. And I have some images. I'm going to turn off these images for now. So let's say I want to set up a basic HMS model. Well, what I do, I can just go ahead and go through that process really fast. We'll compute our flow directions and flow accumulations. So here's the watershed that I'm interested in. I can turn on my images to, let's say that I'm interested in doing this watershed upstream from this street here. So I'll create an outlet point, that street. We will delineate our basins. And then we can define our HMS model. So we'll go to the hydrologic modeling module, set up HMS. And for HMS we need a curve number. I'm just going to enter that. And we need a time of concentration. So my curve number, I'll enter a curve number of 90 for this area. We'll enter a time of concentration. We'll just compute it using this method. And so there's my curve number for my watershed. Or there's my curve number and my time of lag time for my watershed. So then I need to define precipitation, so I'll define my precipitation, and we'll use this curve, and we'll define a total depth of 4 inches of rainfall. Okay, so I can go ahead and run this HMS model. So I'll save this file. And then I'll bring it up into HMS. So we're going to run HMS. We'll read the file into HMS and we'll compute the simulation. So here's my hydrograph for this model. Okay, and if I want, I can look at this time series table. Here's my time series hydrograph. Alright, well let's say this is a big hydrograph. Let's say I wanted to design a detention basin or a reservoir or something to manage this flow rate, to manage this big flow that might happen. Well, the way I would do that is by adding a reservoir at this outlet point. So I just right click on the outlet, add reservoir. Then I go to the HMS parameters for that reservoir, and I can just double click on it, or I can go HMS edit parameters. And then these are the HMS parameters for this reservoir. So I need to define a storage versus discharge curve. These are the different options that I can define this reservoir with. I'm just going to use this default option. And WMS has some tools that allow me to compute the storage discharge curve or the elevation discharge curve, the curves that I need for a reservoir. So to compute those curves, I go to the calculators menu. First I select this outlet point, the reservoir. Go to the calculators menu, select the detention basins, and then I select this define button. WMS brings up this window where I define my base elevation. My base elevation is just the elevation at that reservoir at the outlet point. And then this elevation is the elevation of the top of the reservoir. So let's say I'm going to make a reservoir with a top elevation of 350 feet. In this case, my units are in feet. I could change my units by, this is actually in the hydraulic toolbox. If I set the hydraulic toolbox units to be metric, then I can change those units, and then I can enter the units in metric here. I'm just going to go ahead and use feet. And we'll do 25 data points. And so WMS, or the hydraulic toolbox, computes this curve that's my elevation versus my storage. So the storage at different elevations. And this is the storage volumes. The other thing I need to do is define my outflows from this reservoir. So how much water comes out at different elevations, how much water exits the reservoir at different elevations. Well, the hydraulic toolbox has tools to compute those curves, and click on this button to use those tools. So let's say this reservoir has a spillway at maybe 100 feet below this elevation, this base elevation, and the spillway length, let's say it's 30 feet spillway length, and then the height above base elevation is 100 feet. We're just going to use a rectangular spillway. Let's also say that it had this detention basin or reservoir has a riser, which is a pipe coming out of the ground, and it exits through the reservoir. And the riser has an opening width, and this is an opening on the side of the pipe. And let's say the width is 3 feet and the height is 3 feet. And you can do a rectangular opening or a circular opening. And you'd find orifice coefficient. And the height above the base elevation to the bottom of the opening, let's say that's 10 feet. So 10 feet below the bottom of the reservoir is where this hole is that lets water in. You could define several of these risers in a reservoir. I'm just going to define one. Hit OK, and then the hydraulic toolbox computes the discharges at different elevations in my reservoir. Then I can click OK here, and then WMS will plot this curve that has my elevations, and for each elevation I have a storage as well as a discharge. The discharge is shown in black, the storages are shown in yellow, or kind of orange yellow. Then I need to map this to my hydrologic model. So we're going to map it to HMS, and we're going to have an elevation curve, a volume curve, and a discharge curve. And then I can go to HMS, to the reservoir parameters, and if I go to the storage discharge curve, so here's my curve of storage versus discharge. So now what I can do is run HMS. I'm going to save this file out with this reservoir. I'm just going to overwrite the existing file. I'll go to HMS. And I'll read in that project. And if I look at this project in HMS, you'll see that so for this element I have a reservoir defined, and these are the reservoir parameters. So I can go ahead and run this simulation. Let's run the simulation. And if I look at the results, you'll be able to see this time series table. And this time series table has the inflow coming into the reservoir. So this is these are the inflow values. my peak flow is pretty high, you know, 13,600 CFS. The outflow coming out of the reservoir is a lot lower, and so my outflows are like 300 CFS for the 360 for the maximum. So it significantly reduces the outflow from the reservoir to have that reservoir here. I could also view just the outflow curve. So this is the outflow from the reservoir, and there are different curves you can view, as well as the hydrograph. So this is the inflow hydrograph, and then this hydrograph, it's kind of hard to see, but down here at the bottom, that's my outflow hydrograph from the reservoir. It's so low that it's a lot lower. And so that's how you do detention basin or reservoir modeling in HMS. So any questions about that, about those things?
Yeah, is it possible to put this detention in some fashion, like not only on the outlet, but between basin?
Yeah, so I could, if I wanted, I could subdivide this basin. And then, you know, redelineate my basins. And then I could define a reservoir at I could add a reservoir at this location. And then for that location, I just define, I do the same thing, so I would go to calculators, detention basins for that location, and then I would do that same process. So I define my elevation of the top elevation of my reservoir. So let's say it's like 1,000 feet, something like that. And then the hydraulic toolbox computes this elevation storage. So it's just the same thing. And then I map that to my model and run HMS, and it'll run that. So
You let the other one, like reservoir also. We can take into account the water within and
So you're wondering if I could do both reservoirs?
Yes.
yeah. So I mean, what I mean, if the second reservoir will the effect of the water already stored in this reservoir will be shown in the next one.
Yeah, it's gonna do all that. So, any other questions?
He takes the first reservoir into consideration when calculating the amount of water with the downstream reservoir.
Yeah, it takes. So if I have several, I can have as many reservoirs as I want,
Yeah.
and heck, HMS will compute the amount of outflow from one reservoir, and it'll put that into the stream just beneath the reservoir, and then it'll route the flow through all the reservoirs in my model. So I can have as many reservoirs as I want, and those will be modeled correctly.
But if the storage capacity upstream is not quite enough to store all the amount of water coming
Yeah.
from the upstream.
So if that overflows, or
yes,
yeah.
aware of something, overflow some water.
Yeah, it'll model that. And you just model it by you can add a weir, which represents your spillway, and you can add a riser, which represents maybe the outflow pipe from the reservoir. If you have a standpipe is a pipe with an opening at the. Do you know about standpipes? It's a pipe with an opening at the top of the pipe. You can also do that. So if you have an opening at the top, you can model the opening at the top, or if you have an opening on the side, that's a riser.
You mean like a telescope, for example?
What's that?
Like a telescope, for example?
I don't know.
To keep the elevation, the surface water elevation constant rate.
Yeah, these are just outflow pipes from the reservoir that you're adding. All right, anything else? So any other questions about this? So I think that's actually all that I was planning on talking about for now. So I think the rest